Okay, hello guys. Today our topic is about the relative and expected frequency. Okay, so let's move to the first part about it. Okay, so first we have two kind of probability. First is called the theoretical, and second is called the experimental. Okay, so theoretical probability means that maybe here we have expected of probability. For example, like we are just throwing a bug. Okay, maybe here we can set probability for the heads that is for 0.5, right? Okay. And maybe when we're just doing the real experiment, we'll find that there's an experimental probability, okay? So for here, like you're flipping a coin for 10 times and you'll only get 7 heads, okay? So you are said that here, the probability equals to 7 over 10, right? The probability were equals to the condition or number of events in condition or number of events in success over the total number of events, right? Okay, that is experimental probability. So in the IGCSE mathematics, maybe for experimental probabilities, usually called a relative frequency, okay? So please remember that there's a difference between two kinds of the probability, okay? They're very easy to understand, right? Okay, so let's move into the next part about how to calculate the relative frequency, okay? So also the same as before, like the relative frequency can be considered as the number of the successful trials over the total number of the trials in the experiment, okay? So for example, like here, a pin is dropped for 50 times and it lands point up for only 14 times, okay? So we can say here, the relative frequency of point up equals to 14 over 50, okay? That equals to 0.28, okay? So we can say that the possibility for point up is for 0.28, okay? That is the relative frequency, okay? And also we have a law called the large numbers laws, okay? So what is large number laws mean, okay? So here it means that maybe when we have a number increase, the relative frequency will get closer to the theoretical probability, okay? So for example, like you're throwing dice, okay? Maybe you want to get the dice number as 1. So maybe you're throwing for 10 times to get 2. So that probability here is 2 over 10, right? Okay. But for theoretically, we said that the probability equals to 1 over 5, right? So, sorry, 1 over 6, right? So maybe you'll find that maybe when you're throwing dice is bigger, when you can find that the two numbers can be very closely to each other, okay? But that is a law of large numbers. That not means your expectation is not true. That means that you have not get a large number of throws or large number of trials, okay? That is the lure of it. And we have the expected frequency. We can say here, expected frequency equals to the probability times the total number of trials. Okay, also very easy to understand, right? So maybe you're expected to like is it 10 1 over 10 for expected frequency. Oh, sorry, probability for the expected frequency is 1 over 10. So maybe for 10 times of trials, maybe you're expected for only one successful trial, right? Okay. So we can just bring down the formula as E equals to P times N, okay? That is the expected frequency right here, okay? And for example, like here, the question is the probability that is a BS dice lands on 6 is 0.2, okay? BS means that here is not a very fair dice, right? Okay, so the dice rolled 300 times, and how many times would you expect to land in a 6, okay? So we said that the formula before is for E equals to P times N, right? So E is expectation and probability times the number of the trials, right? So here is also the same. Number of trials is for 300, right? And the probability here is 0.2. So we can time them together. So 0.2 times 300 equals to the like expected trials, okay? So that's for 0.2 times 300 equals to 60, okay? So we have expected time for 60 times, okay? That is expected frequency right here, okay? And also we have the deliberate practice for you, okay? So let's move to the first problem. A student rolls a six-sided dice for 120 times. It lands on 38 times, okay? So first problem is, what is the relative frequency of the rolling a 5, okay? So maybe we can say here, rolling a 5 that is 120 times, and here we have to times 1 over 6, right? That is a relative frequency, okay? We can say here it equals to 20, okay? That is a relative frequency. And the problem that the suggest dice is biased, explain why, okay? So you can find the real the dice is for 38 times and this is for 20 times, they have a very big difference or very different gap, right? So we can say that it's a BS dice, okay? Because there's a quite big difference between 20 and 38, okay? And for second problem, the probability that a seed maybe here is for 0.85, okay? And the farmer plants 400 seeds. Okay, so how many seeds should the farmer expect to grow? Okay, so that is for 400 total number of events times the probability 0.85. Okay, so finally it will get 85 times 4, it equals to 340. Okay, so this value is an expected value for the farmers to gain the seed. Okay, that is for second problem. And for third problem, a spinner has color red, blue, and green. Probability for red is 0.4 and probability for blue is for 0.35, okay? And the spiners is spawned for 200 times. So here we can set just using the rules like 200 times the 1 minus other two possibility, 0.4 minus 0.35, okay? So we will set that here probability is 1 minus 0.4 is 0.6, 0.6 minus 0.35 is 0.15, okay? That equals to maybe for here is for 30, right? So here we can say that the times of the story on green is for 30, okay? Just using the number of the events times the probability right here, okay? That is estimated times we throw and we get this number, okay? Okay, that's for today's our lesson. I hope you can understand it for how to calculate the frequency, how to find the relative and expected frequencies. Okay, they are very important for you to understand and solve the problems. Okay, so that's for today's our lesson. See you next time. Bye.